And it is just simply called operation on function, or operations on function, mathematical operation. Adding, subtracting, multiplication, division, and something else called composition. So we are going to be taking a look at 5 mathematical operations, and we're going to be applying them to functions. Not only will we be applying them algebraically to functions, and primarily it's going to be algebraically, but we can also do this graphically to functions. And applying operations to functions graphically is very difficult. However, it'll be made much easier when you're in the next course. So just to remind you that no matter if we decide to work algebraically or graphically, these two forms are equivalent, and it just goes to show you that there is a deep connection between algebra and graphing. So we're going to be taking a look at addition. So I'm just going to cover up everything else. The operation is addition, the notation. If we want to add 2 functions together, f plus g of x, how do we get that? Well, f plus g of x simply is f of x plus g of x. I guess what we're trying to say here is we're going to add the 2 functions together, f of x and g of x. That's how we do it. Next operation that we're going to be doing is subtraction. F subtract g of x. Now, that's the notation that we're going to use. The resulting function is f subtract g of x. And that is just starting off with f of x, and we're subtracting g of x. Just like with numbers, order matters in subtraction, but it does not matter in addition. The next operation we're going to do is we're going to multiply functions. F times g of x. Now f times g of x is equal to f of x times g of x. Division. F divided by g of x is f of x over g of x, but make sure we don't break this rule that g of x cannot be equal to 0. Really fundamentally important. Composition is our new one. Composition, now this, in contrast to multiplication, which is a solid dot, this is a hollow dot, and it is read as the following. F composed of g of x. Well, f composed of g of x is equal to the f of x, or the f of g of x. Stated another way, our input for our function f is g of x. So that might have to get some getting used to here. So let's just work on an example here. And 4 questions, these 4 questions I'm hoping are going to cement my understanding. So I'm just going to write f of x. Now f of x is 2x squared plus x, and g of x is simply x minus 4. And I got that from the question here. So I'm just going to start on the question. Hopefully we can get started. A. I'm going to calculate f plus g of x. The f plus g of x, so I'm just going to write f plus g of x is equal to f of x plus the g of x. So really, my instructions for f and g are simply added. And the function f is 2x squared plus x. That's f of x. Plus my g function plus x minus 4. So when we add these two functions, I should get 2x squared plus 2x subtract 4. Just simply, I'm adding the two polynomials on the right-hand side. So that is my function f plus g of x. That's how it's done. So to create space, I'm going to move all the way over here now, b. I am going to do f subtract g of x. Now at the end of this, I would like to ask you, how does this differ than g minus f of x? So there's my notation that I use, and I know that f minus g of x is going to be f of x minus g of x. So I take a look, what is f of x? F of x is 2x squared plus x. I'm going to put that in brackets to avoid confusion, minus g of x. And g of x, as I stated up here, is simply x minus 4. If I combine these two terms, the resulting function will be 2x plus 4. So f minus g of x is going to be 2x plus 4. Now, c. I think you are probably getting the hang of this. c is f times g of x. What does this mean? In the function, we take the function f of x and we multiply it by g of x. My function f times my function g. Now, just so you know, this might get a little bit nasty simply because we're multiplying two binomials together. So this would be 2x cubed minus 8x squared, if I multiply this term with this term. Now plus x squared, x times minus 4 is minus 4x. So my resulting function f times g of x is equal to 2x cubed minus 7x squared minus 4x. All right, there's something now. How do I graph this? And this does have a graph. I guess we'll see. D. Now, D is likely the simplest one. F divided by g of x is equal to f of x divided by g of x. Now I'm just going to make sure that I include that g of x cannot be equal to 0. I'm going to continue on. Don't really need that much room for this one. So f of x is 2x squared plus x over g of x. G of x is 4, or x minus 4. Now we have to consider what value of x makes my denominator equal to 0. So x cannot be equal to 4. There's my non-permissible value that I must include. So that was f divided by g of x. Hope you're having fun with this. Now let's just take it up a level. So I'm going to do E on this piece of paper here, starting brand new. So E. And I'm going to call it quits after E. E is f composed of g of x. So just so you know, whenever I'm doing composition, I like to include colors so that I don't really mess up. So I underline g of x here. Now this might get a little bit nasty. So if I take my function f, this is the definition of my function. F composed of g of x is the f g of x. Now it might be important to remind that the order is maintained. F, g, x, f, g, x. So this is f of g of x. So now my input for my function f is my output for g. Or another way of saying this is I'm going to maybe work inside the brackets to the outside of brackets. Okay? So for instance, f, what is g of x? G of x is x minus 4. Now we've seen this in the previous example, in the previous lesson, where our input turns into an algebraic expression. Now I have to sort of think quite carefully, what does my function f say? My function f is simply 2 times my independent variable squared plus my independent variable. Oops, sorry. Plus my independent, I got excited there. Plus my independent variable. So what is the input? It's x minus 4. So now I carry out and I try to simplify this algebraic expression. So on the right-hand side of this equation, this is a perfect square. So if I square x minus 4, it turns into x squared minus 8 plus 16 plus x minus 4. So what did I do there? You may have to multiply that out, but that's really just x minus 4 times x minus 4. I continue this further, simplifying the right-hand side. I have to carry my multiplication. This first term simplifies to this, plus x minus 4. So now I'm going to combine like terms if I can. There's no term like 2x. Negative 16 plus x is negative 15x. 32 minus 4 is minus 28. I'm hoping this is right, as it is quite complicated. So the f composed of g of x is equal to 2x squared minus 15x minus 28. So what I would like you to do is, on the next page, simply graph what does the resulting function f plus g of x look like. What does the resulting function f minus g look like? What does the resulting function f times g look like? What does the resulting function f divided by g look like? What does the resulting function f composed of g look like? And I really think that this, don't labor over these graphs, but it does open up the possibility of what is to come, I think. Hope you enjoy.